Hi, pre-calculus students. Welcome to section 4.5, transforming cosine and sine graphs to match patterns in the real world. So we already spent some time looking at the sine graph on its own, and then important characteristics of a cosine and sine graph. And now we're going to be doing some real transformations and writing equations that cause transformations of the sine graph and the cosine graph. So let me go ahead and share my screen here. Right, so you have your notes in front of you for 4.5, right? And we're going to be working on this together. So first of all, on the first page, the basic equation for transforming a sine or cosine graph is A times sine or cosine, where the angle is being multiplied by B minus C. And then the function has a plus D being added to it. And of course, that can be positive or negative. So I just give some notes here, how to graph and find characteristics in this order. So the first thing I do is I find D, which is the midline, and that is related to a vertical shift. So if there is no D, meaning that there's a plus 0 for D, then notice for the cosine and sine graph that its midline is the x-axis. So if you do not see a plus D in a sine or cosine equation, that means that the x-axis is still the midline. If you have data, a list of data, the midline would be your highest point plus your lowest point divided by 2, right? Because that would be an average. The A that is multiplying the sine or cosine function, the absolute value of A is called the amplitude. And it is like a vertical stretch or compression. It is the distance that the highest point on the sine or cosine graph is above or below its midline, right? And so it's always distance is positive, so the amplitude is positive. But please remember that the graph itself could be reflected over its midline, right? If you see that the original A value is negative. So if you have data, that would be the highest point minus the lowest point divided by 2, right? Because that would be the distance between the highest and lowest point on the graph. And when you divide that by 2, that gives you half the distance. Okay. Again, it's related to a vertical stretch or compression. A itself can be positive or negative and helps with graphing, but the amplitude is always positive. So note, this is important because on our second graph that we're going to do together, if your A is less than 0, then a reflection over the x-axis occurs, right? We knew that. If you multiply by a -1, you'll see a reflection. Now, let's talk about a new period. So cosine and sine both have a period of 2 pi, meaning that a sine goes through a full cycle of its upper loop and lower loop in 2 pi or 360 degrees. And cosine does the same. Cosine at 0 starts up at its highest value of 1 and ends up at its highest value of 1 at 2 pi, going through a full sine. So a new period involves the use of B in the equation. That is the value that is multiplying your angle. 2 pi divided by B would give you the new period, right? Has the period stretched from 2 pi to 4 pi, and so your graph is stretched out? Has the period been compressed, horizontally compressed to be less than 2 pi? So again, B is the entire value multiplying X. So if you see the angle being divided by a number, it's actually being multiplied by a fraction, okay? And again, this new period is related to a horizontal stretch or compression. So what I do when I'm graphing is I do steps 1 through 3 first on the graph. I first find the vertical shift and I draw my new midline. I then find the amplitude and how high up and below the midline is the graph going. And I do draw those lines to create a vertical boundary. And then I get the new period and I draw vertical lines to make a horizontal boundary. Okay. Then what I do is I graph one cycle of the sine or cosine graph because I understand how they look as a parent function. The next thing I do then is number 4 is C in the equation divided by B is the phase shift, right? And so that means that is if we've moved the graph horizontally left or right, there's just has its own special name. It's called a phase shift, right? So when you're working with sine and cosine in trigonometric functions, right, they have their own vocabulary. Shifting left or right is called a phase shift. A vertical stretch or compression is called amplitude, right? They have their own words. So now if the phase shift is greater than 0, meaning that it's positive, you will see an actual shift to the right because of the minus sign in the equation, right? Showing the opposite. If your phase shift is less than 0, meaning it's negative, you actually will shift to the left because of the minus sign in the equation. We are still doing the opposite like we do with horizontal. So let's get to how to actually graph, right? So to graph, what I do is I find my D and draw my midline with a dashed line. I then find the amplitude and go D plus A and draw that horizontal line, D minus A and do that horizontal line using a solid line to create vertical boundaries. I then draw, I start with my cycle, of course, at the y-axis where x equals 0. And then I draw a line, a vertical line at x equals 2 pi over b, showing one period where I will make my cycle to. And then now I have horizontal and vertical boundaries, and I go ahead and draw my graph in there. So on number 4, just like it says, I draw one cycle of the trig graph in my boundaries, and I don't forget that if my A is less than 0, that there will be a reflection. And I do draw lightly because it possibly is not my final drawing. Then what I do is once I have one cycle of the graph, using my phase shift C divided by B, I move my horizontal boundaries left or right and redraw the one cycle because now I can see it and it's easy to redraw. And then from there, I draw more cycles to the right of my one cycle and to the left. Okay, but we do more than in this section than just drawing. Let's take a look at the other things that we do, right? So here's some examples. Given that y equals 3 times cosine of 2x, they are asking what the period is. Okay, so the way I find the period is that is using my b value. So notice that 3 is my a and 2 is my b. I have a little formula to find my new period. It is 2 pi divided by b, which is 2 pi divided by 2. And my new period is pi. What is my amplitude? It is the absolute value of A, which is the absolute value of 3, which is just 3. Let's try that again with y equals -3 sine of x over 3. Okay, first of all, notice that in our formula, our angle is never being divided by a value, so it must be being multiplied by 1/3. There we go. Notice that my A is -3 and my B is 1/3. So what is the period? 2 pi divided by B. My B is 1/3. That's a 3 right there. There we go. I will keep my first value and multiply by the reciprocal, and I get 6 pi. So this cosine graph would be stretched out over 6 pi rather than 2 pi. What is the amplitude? My amplitude is the absolute value of A. My A is a -3, and the absolute value of a -3 is 3. Okay, on number 3, let's write a sine equation. If the period is 4 pi, the amplitude is 3, you have a left phase shift of pi over 4, and a vertical translation down 1. I still use the same order that I normally do. So I always start with the vertical shift, right? So there's a vertical translation down 1. So my D is equal to a -1. Next, I do the amplitude, right? That would be my A. So it says that the amplitude, the absolute value of A is the amplitude is a 3, meaning my A then could be a plus or -3. We do not know if this sine graph has been reflected or not. So we'll have to put plus or -3 in the equation. I then go to my B to solve for B, right? And what I know is that my new period is 2 pi divided by B. And they told me that my period, the new period, is 4 pi. So I'm going to set 4 pi equal to 2 pi over B to solve for B. So how about if we cross multiply? 4 pi times B equals 2 pi. And let's divide by 4 pi to solve for B. There we go. And my B is equal to 1/2. Okay, I will write that right here. My B is equal to 1/2. Okay, next let's do our phase shift. It is pi over, it's a left pi over 4. So that means that here is the formula for my phase shift. C over B, right? Notice that I needed the B before I could figure out the phase shift, right? And so that is, I'm just going to scroll up a little bit more here. The phase shift is left pi over 4. That is a negative pi over 4 is my phase shift. Okay, so I'm going to use this to solve for C, right? So I do have my B. So C over B, my B was 1/2, equals this phase shift, negative pi over 4. Okay, couple ways to go here. I could cross multiply again. How about if we do that? Just going to scroll up a little bit more. Let's see. And let's see, that would be a negative 1/2 pi. When I cross multiply here is equal to 4C. And I'll divide both sides by 4 or multiply both sides by 1/4, right? Same. And my C is a negative 1/8 pi. Okay, here's what we have. We have D circling there. We have A, we have B, and we have C. Right, so let's go ahead and fill in our equation. Y equals plus or minus, right? My A is 3 times sine. My B is a 1/2 x minus my C is pi, negative pi over 8. Notice that becomes positive, right? Showing the opposite, left should show a plus sign, and then -1. And there is our final answer. Let's move on to graphing. Okay, we are going to graph y equals 2 sine of 2x plus 1. Okay, let's take a look here. First of all, our d is plus 1. That's a 1 right there. Plus 1. There we go. So that means that my midline has been moved up to the y equals 1 line. And I am making a dashed line right now across the graph. There we go. Let's get our amplitude, right? Our A is 2. And notice that it's positive, so there won't be a reflection, right? So that means above my midline of y equals 1, my graph is going to go up 2 from there. So notice I'm drawing that horizontal line, creating a boundary, and 2 below. There we go. Notice that my B is 2, and so my new period would be 2 pi divided by 2, which is pi, meaning I'm going to make a full sine wave with the upper loop and my lower loop between 0 and pi instead of between 0 and 2 pi. So my boundary then, my horizontal boundary, right, I'm going to start drawing on the y-axis, of course, and I'm going to draw a horizontal boundary with this vertical line at x equals pi. Okay, so notice here's my boundary. Let's make it a little darker, right? I am going to draw 1 cycle of sine right here in this box. So I know sine starts at its 0 at its midline, right? And it goes, the first loop goes up halfway, so to pi over 2, right? So here's my first loop of sine, and then it goes downward for the second half. There we go, and back up. So notice, let's see if I need to move my 1 cycle. Notice that I do not have a C, meaning there is not a phase shift. So I can now just continue my graph, right? Upper loop, right from the midline to my highest horizontal line, and down and back up. And I can also go backwards, right? So I can go, let's see, down. And so pi, there we go. Pi over, there we go. A little harder to go backwards. And then up, right, and down and back up. And there we go. Isn't that cool? We have graphed y equals 2 sine of 2x plus 1 without using a calculator. Let's go down to our second graph. Of course, this time I have cosine. I do have a reflection this time and a phase shift, so I tried to get some different things in there for you, okay? So let's take a look. Let's remember what cosine looks like, right? It starts up at its highest point at 0, and halfway through at pi over 2, sorry, at pi, it's down at its lowest point, and then comes back up, right, to 2 pi. So let's take a look at what we have here, right? We have our D, our vertical shift, we do not have one. So we will still be using the x-axis as our midline right here. So that's 0. Let's take a look at our amplitude. Notice cosine is being multiplied by a -1. So the amplitude is still also 1, but I will remember that it has a reflection. So cosine usually starts at its highest point. At 0, I will remember to start at its lowest point. So I can draw horizontal lines at y equals 1 and y equals -1, but I'm pretty good because I already have a sample cosine wave here of staying within those boundaries. Okay, I don't have, my B is 1, right? So notice that 2 pi divided by 1 is still 2 pi. So notice I do not have a change in the period. So I won't set horizontal boundaries. I will still make a full cycle from 0 to 2 pi, but this time I do have a phase shift. So notice this time I picked cosine, I picked a reflection, and I also picked that there's a phase shift. Okay, so let's take a look here. It would seem that my phase shift then is, my C is pi over 2, right? So let's come on up over here. So C over B equals the phase shift, which is pi over 2, right? Is my phase shift. Notice because my B is 1, this says that my phase shift is simply right pi over 2. Excellent. So I am first going to draw the cosine function, negative cosine of x, and then I will move it to the right too. So I'm going to do this slightly. So including my reflection, my graph is going to start down at 1, at negative 1, right? And go up through 0 at pi over 2, right? And we'll be up at 1, come back down to 0 at 3 pi over 2, and continue down. So there's one full cycle of cosine that has been reflected. Okay, now how do I move this graph pi over 2 to the right? So what I do is, my starting point was the y-axis here, right? So I'm going to go to the right pi over 2, and right here, make a new starting line, right? And so now I will start down at pi over 2, right? And it will be going through 0 at pi, right? It will be up at its highest point at 3 pi over 2, right? And we'll go through 0 at 2 pi and never makes it fully back down. Let me darken this a little bit, right? And I will continue this pattern backwards. There we go, up through 0, right? Up to 1, down through 0, down and back up. There we go. Let's see then if I can highlight that so you can see it a little bit better. I haven't used the highlighter before. I'm going to highlight my final graph. So my final graph that I had, oh, it does not want to do that. Let's see if I can move that back over. Okay. Okay, I thought that it would do that for me. Let's see if I can go back to highlighting. And again, I will just make my graph, my final graph, darker. There we go. Okay, there we go. Okay, and there we graphed cosine with a reflection and a phase shift of pi over 2 to the right. So I think we've covered everything that you will need to help you with section 4.5. And of course, it'll be great to go over that in class. Have a good day.